Okay, for people joining this live stream, we are talking about game theory, and this is a topic that we've been had lots of pieces for in Wolfram language for years, but we've been meaning to have a systematic treatment of it in the language. And I see somewhat disappointingly that there are notes that I have from September 2018 of the last version of this iteration. So we are plus 3 years, and hopefully Joseph here is going to um, uh, um, I think we could leave that out. Is going to show us how to make this work. Okay, so let me just understand the scope. Okay, so we've got matrix games, game trees. Okay, I did some work on those recently in connection with multi-way systems. Bayesian games, which I don't know what they are. Iterative games, I understand what those are. Evolutionary games, I have no idea how we're going to parameterize those. And coalitional games, which I don't understand. So, okay, so now Joseph has proposals for functions. Okay, all right. Explain. Okay, game can be defined by a utility tensor. N is the number of players. M is the cardinality of the ith player's action set.
So, Stephen, I have a few examples, many examples on a notebook.
Good. Do you want to just send it to me or?
Yes. Well, I can send or I can show.
Okay, why don't you show? Why don't you show?
Okay, I show these. Now share my screen. Oh.
Okay, go for it. Yep.
Share screening, yes. And here it is. Okay, so
let's start with matrix games.
Yeah, okay. So in case of matrix games, first of all, I want to show some kind of design. So there are pre-implemented games, like for example, the Prisoner's Dilemma, and it would look like
okay, but that's clearly not going to be called GPD. It'll be called Game of Quotes Prisoner's Dilemma.
Yes. Okay, so here everything is initial and temporary.
Okay, all right, okay. So, so this is hold on. So, it might be better if I'm running this notebook. I mean, so you've got two game matrices here for the two players, correct?
Yes.
Okay. All right. So let's just understand what's happening here. So now, okay. So then what we have talked about previously, and you apparently don't agree with this design, is when there are named actions to use an association with named keys rather than a pure matrix. What's the reason not to do that? In other words, why not, instead of having separate action labels and player labels, why not have this thing, this first argument be an association of associations?
Okay, so I imagine this as a hidden object. So in some stage, this game object would be something which is hidden from the user, and then you can ask for different representations if you want. So you could ask for bimatrix representation. If you want, you can ask for an association representation. That would be something which...
All right, okay, reasonable enough. Okay, so fine. So it doesn't matter so much, but people are going to have to, when they're constructing a game, they have to type something in. And it might be convenient for them to type in matrices. That might be a more convenient thing for them to construct.
Okay, I imagine there could be several constructing methods of games. So you can construct it from this association list, or you can have you can construct it from strategic form, from a graph form, etc., etc.
Okay, all right, okay, fine. All right, so there's this game object, and you have a function here, payoff matrix, but that could as well be a property of that game object.
Yes, it could be.
Okay. And if is that just a display thing that we're seeing there, or is that something?
Yes, it
Okay,
is
so
just
fine.
displaying in an understandable way. And this decoration by labels is optional. So the main thing from point of view of calculating equilibria, etc., the main object is
Obviously,
this
right.
payoff
Right.
matrix or payoff tensor.
Okay. Okay. I mean, this output could be more beautiful. I mean, it could be more graphically presented, it seems to me. But this is certainly, I mean, yeah, I mean, that's a detail. But given that this thing is going to be a property of this game object, which I think should be called a game object, not a game. But anyway, okay, so it's just a property that is a display form.
Yes.
I get it. Okay. All right.
Okay, then here are several other examples, like the rock paper scissor. There is this coordination.
So let me ask you this. So the way we would normally do this, like for example, NetModel for neural networks has a repository, right? So in other words, if you have a name first argument with a string, game object of quote rock paper scissors, right? Yes. The clean way to set that up would be to have a repository of games. Yes. That, like the repository of neural nets, where we just have a big collection of these things. How many of these things are there that are named? Are there, 10? Are there 50? How many are named?
Well, on Wikipedia, for example, there is listed, let's say, 10 well-known games without parameters, and there are several 30 with parameters, which are n-player games.
Okay, all right, fine. Okay. So that's initially it could be done just as something where it's documented in the, there's a list of what the possible games are documented in the game object documentation. Yes. And then subsequently it could become an actual repository. Okay, I get it. All right, 3-player game. Okay,
here I wanted to show a 3-player game, that how the structure would look like. So here we don't have only 2 matrices, but it's a tensor actually.
Yep, sure.
And you have to represent it in a nested form.
Yep, just like table form, matrix form, whatever do. But this is fine. This is nice. I mean, I think given that this would be some, there's graphic design that should be done to make this more beautiful, but this is basically structurally makes sense.
Okay. And then here I just implemented a function where you can generate random games, where you can list the cardinality of action sets of given players.
Now, why isn't that just random real of, why isn't that the equivalent of random real, 1, 2, 2, 2, 2, 2?
This is basically that. I just simplified not to include all the time these tables, etc., etc. So it's quite easy. It's just.
Well, why isn't it just game object of random real of 1, 2, 2, 2, 2, 2?
Maybe it is.
Okay, fine. It seems like a specialized thing to want a random game like that. I mean, I know it's an interesting thing to study, but it doesn't seem like it needs its own function.
Yes, here I included an extra thing that you can specify the distribution, etc., etc.
Okay, but fine. That's again something you should be able to do in the, unless there's a special kind of distribution for random games that's different. What is the distribution of those payoff numbers for a random game? Is it not uniform distribution?
Here the default is uniform between 0 and 1, and you can specify something like
right. But the correct way to do that is just to say random real of normal distribution, blah blah blah, 2, 2, 2, 2, 2.
Yes. So, for example,
right. But I don't think this is the right way to do it. Right. Right. So all you have to do is say, if you just type in random real. I mean, you can just do that. Random real. A Poisson distribution of 10. Same thing, Poisson distribution of 10.
Yes.
comma list 222, let's say. I think this will just work. Well, whatever. Oh, integers. Okay. Oh, integers. So you have to say random integer there.
Random variate works for everything.
Okay, random variate. Sounds good. Okay, so that should give you, if you do 4 twos, that should give you the same structure.
I think
Doesn't have the right number of variables in it, but it doesn't have the. Oh, maybe it does. 2 to the 16. Oh, you need it. No, I know what you need. You need one more thing. You need the number of players. The first element needs to be the. Is it the first or the last element? I don't know. Last element, maybe. Go ahead. It's not the right way around. Anyway, it's something like this. Beautiful. Well, that's not quite right, but okay, it's something like that. All right, keep going. This is very nice.
Okay. Then another topic is the game trees. And here is already something which is existing in Wolfram language. So I get this math game decision tree from the knowledge.
I didn't even know we had that. Okay. That's a thing that I was looking for a thing like that. Okay. I reprogrammed that. Okay. All right.
Okay.
So then
I just again I use the data structure here, which I imagine should be
well, so we have a tree data structure. Is that what we want to? So I mean, that's coming in 12.3. So this will be using the tree. So then you would be saying, I would imagine you'd say game object of that tree data structure.
Yes. So that would be again some kind of hidden object. I just show you what is the internal data structure here, what I use. Here we have two kind of nodes. There are decision nodes, which has first of all label. Then there is a player, which player can choose there an action. There is an action association in an association, meaning that if player 1 says A1, then it goes to node 2. If it says A2, then it goes to node 3. And here is an empty list which says that there is no payoff in this stage.
Okay, and so look, hold on. This should be using the this should be using the existing, I mean, the tree functionality that we're building. Do you know how that works?
No.
Okay, so you've reinvented some pieces of it. Okay, so you should be able to just use trees, the tree object. Ian Ford isn't here, is he?
No, he's not, but we can connect Joseph to him.
Yeah, please. This should be straightforward. You do not need to reinvent the tree data structure.
Of course.
Okay.
This is something hidden and initial. So I just.
Okay, fine. But the basic point here is that you have a series of layers. There's player 1 layer, player 2 layer. At each layer, you're representing what happens according to this game tree. But now, where do the payoffs go here?
Yes, I see and those are the leaves where there is no possible action, but there is a payoff for every player.
Quick question. Sorry, this is Jason. For games where the choice order doesn't matter, this is going to work fine. Otherwise, is there any notion of the orders in which players make their choice giving you different trees?
So I would use information sets for that. Meaning that in some cases, the player don't know in which stage he is precisely, only in which subset. And this is how one can model one-shot games or matrix games in this way. This is called the imperfect information game.
Oh, but so wait a minute. Is this no longer a tree?
So an imperfect information game is a tree plus subsets of nodes. So the information set gives an extra hypergraph structure to the tree graph.
Well, I mean, my question is how that's going to work with the tree data structure. What you have to have. Okay, so I don't quite understand that, but that's something.
Okay.
Why don't you try one more time? And if this is a long notebook, it really would be better to send it to me and for me to drive here. I thought we were going to go back to the agenda.
I just sent it to you. You have it in your email.
Okay.
Okay. So can I go on with this imperfect information structure?
Hold on. Let me just it will work much better if I drive, I think. So in that way, it's and this works in just the existing version of our. Right, it works in the existing version.
Yes.
Okay.
First,
why don't you unshare and let me share, and then we can go that way.
First, you need to run the definitions, and then.
Okay. No problem. Let's do that. Okay. Beautiful. All right. Okay. Now let me try to understand this. So. And by the way, it would be good if we can get Ian here. That would be great.
Okay.
Okay. So this is a tree. Each layer in the tree represents. Okay. So what's happening here? I don't quite understand. What is this doing?
So you got player one making a first choice, then if player two making a different choice on either of the trees, he's on subtrees based upon what player one's choice was, right? And at the leaves afterwards, he gets to an actual payoff.
Yes.
But why is that? So I don't understand. I mean, you're going to go down this branch or the other branch anyway. What's the thing? What's the difference?
So the payoff, the payoffs in the end.
Depend on what? I mean, so here
just the mutual choices. So player one chooses to go to the left side or the right side of the tree, and then depend on either of those subtrees, player two decides to go to the right or left branch of the subtree under him, and the payoffs happen at the end, right?
I can see that. Yeah.
This is why I was saying that the issue with this tree representation of them is that this is visually presenting player two as making his choice after player one, right? But it actually is, because of the symmetry of it, it's actually indifferent to the order of the choice, at least in a perfect information case. If they're doing simultaneous choice,
so then what does the dotted line mean?
So if you have them do the choice in a different order, but with different information, there's a question of do I make the choice and tell you, and then you make your choice? That's a sequential game with perfect information, right? But if I make my choice and don't tell you, it's the same as if we made it simultaneously, right?
Okay.
So games of simultaneous choice can be modeled as games of sequential choice with imperfect information.
Okay, but how do you specify the imperfect information here?
So here, basically, the thing is that player two in the first situation knows exactly what was the choice of player one, and in the second stage, the second option, player two doesn't know in which node he is precisely. He only knows an equivalence class, and that equivalence class is
I get it.
Is donated by this dotted line.
I get it. Okay. So in general, as you say, this is a hypergraph.
Yes.
Not a tree.
Yes.
Cluck, cluck. I mean, so it's not completely obvious that you should use having made my case for using the tree representation, it's not completely obvious that that's correct. Well, if you want to cover this case as well.
Yes, if you want to include imperfect information, which is a big class of games, then yes, you need.
Well, but okay, so there's two choices. Either you have a wrapper on top of the tree representation, or it's a completely different data structure. Okay, let's keep going just to get a scope here, and then we're going to go back to more details.
Okay, so here you can see a more complicated game with perfect information. So this is basically the strategic form of a Bayesian game, which will be seen in a later stage. Here there are 3 players. One is special, called nature or God or random or something, which chooses some types. And then the players don't know. So the players know only their own type. And based on that information, they need to make decisions. But by not jumping further, this is just a representation of an imperfect information game, which is a little more complicated than the first one.
Okay.
And here you can see a hypergraph structure that the information sets for player 2 are actually 4 node subsets.
I get it. So I mean, we have, for the physics project, we have a bunch of hypergraph functionality and visualization.
Yes, that's what you will see if you go a little down.
Okay, all right, fine. Okay.
Here I wanted to show that so here, for example, in a Bayesian game, nature can, so we need to specify the probabilities, how the nature works. And maybe by specifying the thickness of the arrows, you can nicely visualize probabilities as well.
Okay.
On these decision trees.
Okay, that's a different kind of hypergraph. So that's a subset-based hypergraph. So there's no ordering in these sets. Is that correct?
Yes. Yes.
Okay.
Yes, and here I just wanted to show that there are 2 standards in literature how these information sets are represented. One is these dotted lines, and the other one is these blobs.
Okay, fine.
And I just want to, I had no time to implement these, but there is a possibility to use blobs as well.
So I mean, roughly what this will be is, I see. Given, I mean, there's 2 different things here that we can do. One is the visualization, where this is fundamentally a graph with, graph layout and all that kind of stuff, but with additional edges. And that's one thing you should be able to get out of this game object, presumably, is something, I mean, you could take any game, even, something specified with matrices, and you could represent it in this form, right?
Well, you can represent any matrix game with an incomplete information game. It's a little harder. It's not obvious if something can be represented by a non-complete information, by a perfect
complete information. Right, that depends. That's a condition on the matrices, presumably.
Yes, I think those are pretty expensive algorithms to reverse the matrix game to a strategic form, but it's possible.
Okay, but so roughly, design-wise, if we have a game object and there is an access or a property for the game object that corresponds to this graph-like representation, then by default it will just be the the thing assuming incomplete information with dotted lines and so on. And there's a completely separate issue of trying to reduce that game to one that is a complete information version of the game tree version. Is that the right way to think about it?
I'm not sure.
So I mean, I would think that this would be what would happen. You would have game object of, I don't know what was this one? What is this named game? I'm already losing. Okay. Matching pennies.
Yes.
Okay. So then it would say something like this, and it would just say the simplest case would be just something like, whatever it is, decision tree.
Yes.
And that would return a graph object. And then you could put options onto that graph object.
Or a decorated graph object, I think.
Well, it's any graph object is a decorated graph object.
Okay.
Okay, it's either a graph object or it's a tree, but it's probably a graph object from what you're showing me here. Okay. is this? Okay, terrific. Okay, and then
I think one more useful thing would be to actually combine different games. So if you have three representations of games, for example, then you could say that one leaf node is not anymore a leaf node, but start for another game. So I think
Yes.
that's how you could combine these games, and that's how you could construct more elaborate games from simpler ones.
So that will presumably have to be its own function for games, right? Because it's going to take game objects and it's going to take, I'm not quite sure how I mean, it's similar to a graph union. As a graph, what is it similar to? For a tree, actually, that's an interesting operation for trees that I'm not sure we've thought about that clearly, is, what happens when you want to graft a tree on by putting a tree on the leaves of a tree?
Yes.
Okay, this is great. All right, game trees into matrix games.
Yes.
Okay, fine.
So here there is a transformation. Decoration could be added, but basically what I wanted to show that these kind of tree forms can be transformed to matrix forms.
But I mean, look, the way this is going to work presumably is you type in game object and you either give a tensor here, that's one case, in which case here you could say decision tree or decision graph or whatever you want to call it, and then that returns a graph, and that's your way of doing the transformation. Or you put in here game object of whatever the tree representation is, and then here you can say whatever your thing there is, payoff matrix, if you just want the display, or if you want the actual matrix, well, that will presumably give you the matrix. And then payoff, I mean, I don't know what the name for it is, payoff matrix. I'm just making up this thing because I don't think this is quite right, but something like this, which would be the graphical version like this.
Well,
does that make sense?
The thing is that different game trees can give the same matrix structure. For example, for these matching pennies, you can permutate the players. Okay. If player 1 has complete information,
I get it. Yeah, I get it. So what?
I just say that maybe keeping this game tree and game matrix object can be something justifiable, because also if you have a big tree, then
the cost of a new object is extremely high. Mm-hmm. The cost of every new object is supporting it in n functions, right? So it's usually a bad idea to have, multiple. But let's keep going.
Okay. The thing is that if you have a bigger tree, then the possible actions of different players have a combinatorial explosion.
I understand. Okay. I understand. So, but you just explained that this game object is an opaque object, right? So it gets to represent itself internally however it wants.
Mm-hmm. Yes.
Right. So all you're doing is you're saying, I want the decision tree for that. Fine, you get a graph. I want the payoff matrix. Okay, fine, you'll get a tensor. And if you've got 10 players and your tensor is a huge, 2 to the 10, whatever it is, size, 10 to the whatever it is, size thing, then so be it. Right? I mean, if you ask for the matrix, you've got to be given the matrix, which might be huge.
Well, the thing is that if you represent a game in tree form, then maybe it's impossible to calculate the exact Nash equilibria for everything, but maybe you can use an approximative method where you don't need to transform that into a matrix.
I get it. But I mean, the only reason we're talking about transforming to a matrix is if the user asks for it.
Okay.
I mean, I think, with your argument that game object should be an opaque thing, which, you know, is maybe just fine, then, you know,
so I think it's something like matrices and arrays and sparse arrays. So
yes, but those are very expensive. Those sparse arrays took probably 5 years to implement.
Well, okay.
Right. That's why we don't want to do that. If we don't need to, you know, it's okay, let's keep going. This is very nice, by the way. I just want to say that this is a great deal of progress already, and we've only got to the first part of the agenda.
Yes.
Really great progress. Okay, let's look at game solve.
Okay, so in game solve, I just wanted to show how the input and how the output would look like. So here, for example, you have the payoff matrix of the prisoner's dilemma, and game solves gives you a pair of strategies. Here, for example, this 0, 1, 0, 1, meaning that both players should defect in the Nash equilibrium. And then I just visualized how with this stream plot, if one player can tune its own strategy and the other player can tune the other strategy, then how would these strategies flow in this space? So this is not exactly a replicator dynamics, but something similar to that.
Okay, hold on. So first thing is this initial game solve, you know, for example, one solution is the Nash equilibrium. So that's potentially a second argument to game solve that we discussed a couple of years ago.
Yes. I think that the default goal or should be the Nash equilibrium. I think that's the most frequent question. And then you could ask different questions or refine equilibriums.
Fine. But so this thing here of evaluate strategy,
yes,
that list is somehow a representation of the strategy.
Yes.
And
so it gives two separate things. First of all, it can give several Nash equilibria. So from this, you can learn that there is only one unique Nash equilibrium in this situation.
Where is the definition of that crazy G, whatever the heck it is? Or is that already defined? If I run this, is it going to work? Oh, yes, it did work. Yeah, okay, fine. I don't know why it's still blue, but that's okay, fine. Okay.
Yes, so from this output, you know that there is only one unique Nash equilibrium, and then it gives you the strategies, the mixed strategies of both players.
Okay.
Okay, we can.
So in general, though, I mean, there are more complicated things that happen with some games where you don't have point solutions and so on.
Yes, you will see those.
Okay, all right, fine. Okay.
Okay, so here is, for example, a coordination game where more interesting things happens. Here you have three separate Nash equilibria. One is that both players goes to Bach, then to Stravinsky, and there is a mixed Nash equilibrium as well.
Mm-hmm. Okay.
Okay, here again you can see some kind of stream plot or something similar to Replicator Dynamics, where you can see that there are two stable points, 0, 0, and 1, 1, and there is one saddle point, which is still a Nash equilibrium, but not, well, if you have two populations, then this is not evolutionary stable point.
Nice. Okay, very nice. All right. I mean, I don't, yeah, okay, fine. Yep.
Okay, then here we have another one. This is pretty similar to the coordination game, but with some twists. So this is a whole dove play, And here again, you have 3 separate Nash equilibria, 2
Okay.
pure and 1 mixed.
Okay.
Okay. And then I wanted to show what's happening if you have a multiplayer game. So here you have 3 players and they can go to 3 different composers, Stravinsky, Bach, and Dvorak. And here, for example, you get 7 separate Nash equilibria.
Okay.
And they
I
are
mean, but this is not structurally, I mean, so each one, I mean, the difference here between because we don't have named, because these are not associations, we don't have named players, we're just representing which player is which positionally. So,
yes.
I mean, in the case where, in this initial case, we just have one, yeah, okay, so you've nested the lists correctly here.
Yes.
Okay, good.
Yes, so these here, decoration can be used, different output forms can be used, but the basic information, what would be outputted is
okay, I get it. It makes sense.
Incorporated here.
Right, and this thing in general is a tensor, which is, yeah, number of solutions, and then within each solution, it's just a list of n tuples for each of the
possible
it's the mixed strategy that each player has. So, 2/3 of the time he says this choice, 1/3 of the time he says that choice.
Yes.
Right. Okay.
Here I wanted to show that here is a modified version of this, where the 3rd player likes very much his favorite composer. And I just wanted to show that this can output symbolical solutions.
Right. It's always a better idea to have the input and the output paired with each other. Otherwise, you have to go back and see what, I can see that this is paired with that, but if you just had that as the input line, it would be easier to understand. But okay, yeah, all good. This is very impressive. It's very cool. And presumably, if I had a symbolic variable in here, it would still work.
Well, not with this initial implementation, but there is no obstacle. Well, there are, I think that would be
it's complicated because there's a question of genericity of values.
Yes. So there are a lot of if and so if you tune the parameter, it can change the number of equilibria.
Of course, right. So we've had to address that issue in reduce, for example, as opposed to solve. And I mean, that's what reduce has, full sort of conditional expressions and so on to represent things like that, to represent solution sets, which can have where the structure can change and so on. And I think, that may be, that's a future enhancement. But yes, that seems like it would be a very, to have that full thing as you would get from reduce rather than from solve seems like a good idea. Because that's what you have to have. You're not going to have any choice about it. It's going to, in general, you're going to have all kinds of merging, branching, whatever, as a function of parameters, right?
Yes.
Okay.
Here you have something similar. So if you want to, it's another game. It's a rebellion game. If everybody wants to make a rebellion, then rebellion happens and everybody is happy. Otherwise, if the rebellion failed, then those who tried it get a kind of punishment, and who don't try, they are just okay. Here again, I wanted to show that here you can calculate it symbolically as well. So there are pi, and
yeah.
If you are very hacky, then you can change pi to a variable, but it's not very safe. And here is just a visualization how that would look like, because here every 3 players has 2 moves to.
Oh, look at that, conditional expressions.
Yes, but well, I tried that and
it's not going to work. I'm going to tell you right now, it's not going to work, because the structure is, as you've observed, the structure is going to change.
Yes.
in general. And so you're not going to be able to do something where you have a fixed collection of lists. You will have to do something like what reduce does.
Yes, so it gives something, but it's not correct.
No, I understand. So it's not going to work. So you shouldn't. So potentially, what you should do is, if you have game solve, have a second argument which says what kind of thing it's generating. One of the things it generates could be some kind of symbolic representation, which will be like what reduce produces, and which will not resolve into explicit lists until you give values to the variables and so on. But where you can manipulate the thing as a symbolic object, and it'll be very nice. And it's essentially a generator of complicated, expressions.
Okay, then here is just another rebellion game. It's not very
all right, fine.
interesting. Here I wanted to show what's happening in a matching pennies, because it has a nice stream plot. Here it gives you 1/2 mixed strategy, and it can happen. So two things.
These are magnificent pictures. I mean, this is very helpful in understanding what's going on in these games. Yes, go on. Yeah.
Okay, so that's it. And
well,
then
actually, let me just understand for my moment of actually understanding what's happening here. So in a picture like this, we're saying P and Q are probabilities.
Yes.
And when we follow this stream plot around, what are we thinking that the successive, arrows correspond to?
Yes. So the first player can manipulate the P, and the second player can manipulate the Q. And the first player is interested in maximizing the first payoff matrix, and the second player is interested in maximizing the second payoff matrix. And they change their parameter in a way where they can increase their payoff.
I understand, but so this is
then the other person. The other player then adapts by changing theirs, and the result is that they circle.
Okay, so this is an iterative. I mean, that one is imagining that the game is being played iteratively.
No, this is not this is not iterative in the sense that each person has a choice of pairs out of this. It's not explicit iteration where you can train the other player or they react to past. It's just that if you pick this parameter, they should pick that parameter, and the incentives of what you should do given what they do are.
Right, but so this is in a sense, it is iteration, but where instead of having some realistic algorithm for what each player is doing, it is at every step the player is optimally picking what they should do. Is that correct?
Well, you can imagine this as a very gradual iteration. So you don't always choose the optimal the best response for the other strategy. You just always make little incremental changes in your own strategy.
Yeah, so I mean, this is what the stream plot is actually showing is what would happen if you were ignoring the other player's reaction and just making infinitesimal changes to your existing mixed strategy, right?
Yes.
And then they do the same thing. You would be walking along each of these curves.
Oh, I see. So this is basically just representing. I see. It's representing, given this result.
I should change my if we're in the lower part of the diagram, right? And I'm the player controlling P. I should keep reducing the value of P, right? I should make my choices more likely to be 0 and less likely to be 1. And as I do that, the other player is going to see that they can improve things by increasing the probability that they pick 1 as opposed to 0.
Right.
They're going to
so
increase
this
Q.
is sort of right. This is just kind of inside the calculation of something like a Nash equilibrium. This is the were we to calculate that iteratively as a matter of numerical analysis, this is what we would see in the calculation.
Yes.
Okay.
Well, it's a naive approach for that.
And
yes.
obviously, but that's the right. Okay.
Okay, and here I just wanted to show again another game. This is called Rock, Paper, Scissors, Fire, Water. It has a non-trivial equilibrium, and it just gives the equilibrium that whatever that it has one Nash equilibrium and a mixed one where you should choose rock, paper, scissors with probability 1/9, and then fire, water with probability 1/3.
Okay, I get it. I can read that. But I mean, so getting out that graph, which is the, what's on top of what type thing, how does that graph, in terms of, your matrix, decision tree, etc., that graph is yet a different representation of what's going on in the game?
No, it is not organically fits into this, and it's not generalizable. I just wanted to recreate the same plot, what is just a copy of an image.
No, I understand, but this is somehow, why is it not the case that in a game, this is saying water wins over fire?
Yes.
Right? And so that's saying, in terms of payoffs, that would be saying, I mean, you could pick the payoff arbitrarily, but it has to be the case, presumably, that when you represent this as a matrix, this payoff is larger than that payoff. Is that right? Is that how you're representing what's going on here?
Yes.
Okay.
I mean, in this, so this is a 2-player zero-sum game, and I would need to think about that, how this generalizes to other payoffs.
I would have thought that there's a way of drawing it that is not actually that dissimilar. It's a discrete version of what you're drawing above with your stream plots and so on, because this is basically saying, and if I'm not mistaken, the stream plot, well, it's not quite the same thing, but there should be a way of taking some collection of numbers, taking both an adjacency matrix and creating some collection of numbers consistent with that adjacency matrix, because these are arbitrary. I mean, I could have picked 2s and 3s and whatever else, couldn't I here?
If the ratios of payoffs differ from one cell to another, it would actually change where the Nash equilibrium is. But if you just change all the -2s to all the -1s to -5s and all the +1s to +5s, it wouldn't make any difference. So
right.
any scalar multiplication of this is going to make a difference. But if you change the payoff of water beating fire as being,
I get it. Yeah, right.
It's going to change the Nash equilibrium.
But this plot does not define this matrix precisely. All this plot is saying is that water dominates fire.
Yes.
Right? It's saying
Correct.
That's a bigger playoff than that. So this is a specific matrix that is is a particular somehow, simple. I don't know what, it's just a particular representation there.
Right, but I mean, you can make a plot like this for anything where all of the payoffs are 0, 1, or -1, right?
Okay. Yes.
I'm not sure. I mean, I think you need to have a zero-sum game.
Okay.
Correct.
Okay, let's keep going here.
Okay, so here we have Replicator Dynamics, which is something which is used in evolutionary game theory. The main point is that you can imagine that there are replicators which are using given strategies. In time, in the beginning of the evolution, there is a fixed number of these replicators, and then based on the average payoff for each replicators, they can grow in numbers or shrink in numbers. And the fitness of a replicator is defined by the game and the population, and based on the fitness, there is an increase or a decrease in numbers. Mm-hmm. Okay, and here there is this replicator dynamics, which basically first of all generates the standard set of differential equations, and then it uses ND-solve to solve the differential equation for a given time period.
Right. So presumably, I mean, in the actual structure of this, there should be a way taking the game object, and for a given game object, there is a set of differential equations which are the replicator dynamics for that game object. Is that true?
Yes. This is done internally in this replicator dynamics function.
Yeah, and this is with the single population. So, each is playing against the others with the probability of the weight of that, its representation in the population, right? So there would be other things which will...
Yes, so there are different options. It can be a two population replicator dynamics, meaning that for the role of one player, for the role of the first player, there is one separate population, and for the role of the second player is a different different population. Or you can actually join those two populations, in which case you make the so then they are playing against each other. So, for example, in this prisoner's dilemma case, in the fixed points, it doesn't make any difference. So if the populations are disjoint for player 1 and player 2, both in both ways, in both populations, cooperation will go down and defectiveness goes up. Here, so this is the grouping. The grouping of the populations is given in the final part of this replicator dynamics. So this list in list 1, list 2, this says that there is two populations. In the second case, in this single population replicator dynamics, there is one group, 1, 2, meaning that the two strategies are selected from the same population.
Okay, we are going to run out of time, so let's zoom forward a bit just to get a sense of what's here.
Okay. So here are some other examples. Here, for example, in this Doha game, it matters actually that if it's a two population or a single population setup.
Okay. So these are lovely results, but let's, for the sake of time, these are quite lovely, quite lovely. Okay, I need to understand this thing about multi-population thing, but we're not going to understand that right yet. Okay, I just want to zoom ahead just to see what we've got here.
Okay.
Okay,
so
what
there are
is
also
this going to be?
Approximative solutions for this. There are a few standard things like fictitious game and regret matching. If you scroll a little down, you can see what kind of sequences it can produce. So this gives basically a numerical approximation for.
Wait a minute. This is what this is doing. Is it has some internal model, and it is learning. I don't quite understand what learn strategy means.
Mm-hmm. The idea is you have some algorithm for updating what your strategy should be based on the feedback of playing the game that doesn't know about the game itself, right? But is just trying to approximate to learn in all games. And then the question is, how well can it learn to play this game in terms of what strategy does it converge on with that iterative method?
Well, actually, in fictitious play, you know your own payoff metrics. So you always try to find the best response for your opponents.
Okay, but from a design point of view, if I were to just feed in my own arbitrary function to do this kind of learning, what would be the input to that function? Some time series of what has happened previously in these games, or I mean, how does this relate to, for example,
in general, would have to be a map between your associated choices and payoffs as a pass vector. So you have with some other input information like knowing your own design matrix, your own payoff matrix. And then from that, you would have just a general function from one to the other is a learning algorithm.
Right. So my question is, how does this relate to what we do for GANs, generative adversarial networks and machine learning, which I think have the same issue? Actually, no. I mean, maybe it's more reinforcement learning. That is, you do something in the world, right? So we have functions like. Let's see.
The implementation of this is very, very. So it's much more basic. I don't use any.
I understand. I understand that completely. Right. You do not use machine learning for this at this time, right? No. Although my point is, a function like active classification, right? Basically, you could imagine what in the right design for this, you could imagine essentially plugging in one of these machine learning functions for your strategy learner. You see what I'm saying? So what this is doing is, right, it's got configurations, it's got sampling functions, it's got payoff functions, et cetera, et cetera, et cetera. Right. So it will be worthwhile to look at the design of this, which I don't think is that fantastic, but as a way to understand what, if you were to give an arbitrary function to be the learning function, what would that look like? Because I think that the the ultimate, right, it should be the case that you could just plug in something from machine learning here and have that work. Do you agree?
Yes, the thing is that there are some theorems, for example, about fictitious play, that there are some theorems that if the game structure is this and that, then, for example, the convergence of the fictitious play is guaranteed and things like that. I think that's why some would choose
No,
that.
I understand, but you're not understanding my point. Of course, there are particular choices, right, of what the effective learning function is. Right? There are named choices, like your fictitious play case, right? But what I'm asking is, if you, the user, want to invent your own new way of doing learning, right? How do you do that? You should be able to just give here in this learn strategy thing, I'm not sure this argument structure is quite right, something where you just say, here's the function that will be the function that is being fed data about what's going on in the game. And then that function is going to return things that function is then going to have a representation of the learned strategy.
Yes, it is very similar to a behavioral strategy, where basically based on the game history, you give a move or give a choice, but you can also give a strategy.
Yes. Okay, fine. But so what I'm saying is the design, since that's what we're talking about here, the design should map into whatever design we're using for machine learning, because it should be the case that in a nice, cool, generator of many projects for people, you should be able to use machine learning to learn game strategies.
Yes, okay, I agree. I think those can be harmonized. Yes.
Okay, fine. I mean, as I say, I don't think this is a fantastic design for active classification, but you need to, that would be a good thing to start off looking at. That's very nice. Okay, let's take a look here.
Okay, here the main point is that an n-player non-cooperative game can be transformed to a cooperative game or a coalitional game, where basically the main point is that some players can join together, form groups. They can harmonize their strategy.
Yeah, I get it.
And there they can share the payoffs.
Right. Okay. So we need a way of representing that, which.
Yes, and here is this coalitional game thing, which is represented by a set function, which gives real numbers for subsets and the set of players. And the question, what is answered here, is that what is the total payoff what a coalition can get from in a given situation.
Are these Shapley values the same ones as the ones that are used for credit assignment in machine learning?
Yes, I think yes.
Okay. Okay. Okay.
And here there are visualization possibilities. There is already a transferable utility game package in Mathematica. I had no time to explore that and see what's going on. This picture is just copy pasted here.
Okay. Iterative games.
Okay, so this is the final thing. So if you have a game, you can say that this is iterated. And then you can ask that how given behavior strategies, which are basically functions which give some kind of output based on the game history, would would compete with each other.
Right.
And here, this is kind of a simplified reproduction of the Axelrod tournament results.
Okay.
That how it, tit for tat and random and the defector and the cooperator would play with each other, and then Replicator Dynamics used to see how the proportion of these strategies would change as a function of time.
So, okay. Okay, let's zoom out for a second. This is very, very nice. Well done. You've managed to, we've been flapping around meaning to do something like this for years. This looks like we're finally going to get it nailed. Fantastic. Okay, let me ask some meta questions, okay? Since I don't know this field at all. In what you've shown, what fraction, if I looked at a big game theory textbook, and I looked at all the different sections and so on, what fraction of those do you think you've covered with the things you've talked about today?
So I think there are many books. This whole thing is based on an online course on Coursera. This covers the course 1, and there is an advanced course. And there are some other mechanism designs and things like that. This is not included here. So basically, it includes most of the things what's happening in a standard game theory textbook, and the evolutionary game theory part is an extra. And the iterated games is a kind of so it's sometimes there, sometimes not.
Okay, but so. From a design point of view, okay, next question. It would be nice. I think you have managed to get this to the point where I can imagine this being built-in system functionality. Finally, I mean, we've been flapping around with this for a long time. So, I mean, now the question is, if we do that, how many symbols are we talking about here? I mean, I think that the budget is probably maybe 4 or 5. Okay, it's not 15 or 20 or something. It's maybe 4 or 5, unless, and then, lots of detailed things are then accessed with properties and so on.
Yeah, so I think the game solve is a big function. It can take many options, and it can handle many different objects like Bayesian games, etc. Here, if you want, we can talk about Bayesian games sometimes as well. Now we didn't had, so okay, it's included, and GameSolve can give results for that as well. So I think GameSolve is a big central function in this. Then I think this Replicator Dynamics is also something big and I think useful to have.
And why isn't it just a possible output of GameSolve as the differential equation? Or no, not of GameSolve, of GameObject. I mean, if GameObject is the fundamental thing, then why isn't Replicator Dynamics just a property of that produces the differential equation?
Well, you also need to give initial conditions. You also need to give a time frame. It could also have its own separate options.
I see.
Because
there's all kinds of population interaction dynamics too. Like when you go to spatial games, then you've got populations which can interact only with subpopulations locally, and all the replicator dynamics can wind up depending on things other than the game itself and its solutions that are related to the way the populations interact.
Yes. Also here, you could see that, for example, the rock paper scissors games is oscillating. There are replicator dynamics which tries to shrink those things. So
okay, fine. All right. So there's a third function. What is that function? What does it? I mean, what does it take as input? It takes a game object and it takes certain options that represent. What is the input and what's the output? Is the output interpolating functions, or is the output
You mean for Replicator Dynamics?
Yes.
Yes, yes. The output is a nested set of interpolating functions.
Okay. Okay. All right. We're up to 3 functions. What else? I mean, I see you've got others like game iterate and so on here.
Yes. I think this game tree representation and I think that would be important as well.
But wait a minute. The question is, from a design point of view, is that its own separate wrapper, which is very expensive, or is it something where from a game object you can generate a graph, a tree, whatever, and you can feed a tree or graph in to produce a game object? Am I making sense?
Well, the thing is that in these 2 representations, in the matrix representation and the tree representation, I'm not 100% sure, but I think that there is a different set of information in the strategic form. In the tree representation, you also encode the game play, the sequential information.
Yeah.
In the matrix representation, basically that's how you would tell another person how to play instead of you. That for every given stage, you say what it should do.
But in your argument that game object should be an opaque thing, you don't need to worry about these things. You can just have accessors that pull out whatever information you need from each of these underlying representations. And in some cases, it's not available.
Yes, but I am not sure that the tree representation and the matrix representation is totally equivalent.
It doesn't matter, does it? I mean, in other words, game object has some representation inside it. Certain properties are missing, not available for, if you have the wrong representation, so to speak. I mean, that would be the obvious design way to do it. So that way, it doesn't matter. That is, somebody has given you a game in this form or in that form, and you can still use game solve, you can use the replicator dynamics things, etc.
The thing is that, for example, some refinements of the Nash equilibrium as well. There is, for example, a refinement which is subgame perfect solution, which means that if you have a game tree, then in every sub branch that equilibrium should be an equilibrium. And that's, I don't see that how this could, I mean, for that, you need to know that that game is represented by a tree.
But yeah, right, great, fine. But so in that case, if you ask for that thing and you've got a game represented by a matrix, it says, sorry, I can't tell you that.
Okay.
I mean, I don't think there's any problem with that. I think that the important thing is that by having a single uniform representation, it's just like, quiz, in an interpolating function. How many different internal representations are there for an interpolating function? I don't know. There's a bunch of different forms it can have. But it doesn't matter, because all you care about is that you can evaluate it at a particular point and it does a good job of telling you the answer. And if you ask it, there's a representation of an interpolating function where you can go outside the domain. There's another one where you can't. And if you try and go outside the domain, you use the wrong representation. So it's going to say, sorry, I don't have that value.
Okay.
And it's a very convenient way to package it. We are deeply running out of time here, but this was really good. And I guess we should schedule another one of these to go through more details. But I think, I think perhaps, we gave a few pointers for, how to tighten up this design. Actually, I noticed one comment on our live stream that I just want to handle from Mohammed here, which is about something quite different, but I think I'd like to know what it's about. It had to do with categorical distributions, and I'm not sure we have anybody here who's the right person to handle this question. Didn't implement categorical distribution with conditionals. Oh, well, can somebody send this along to the probability and statistics team, please?
Yep.
That's just not for anybody here.
This should go to Etienne.
I'm sorry?
This should go to Etienne.
Okay. Roger, you are almost unhearable.
Oh, sorry about that. Should go to Etienne.
Okay, fine. Sushma can do that. I didn't know you were here, Roger. Do you have any comments on this whole structure?
I think it looks
design?
pretty good. I mean, it needs a lot of polish and iteration, but it looks promising in my mind.
Right. Do you have any comments on the overall design directions here of like the how many functions question and so on?
I think that there's a lot more to game theory than this, but this is a good start.
Yeah, but the problem is we need to not lock ourselves out of something by having too simple a form for this.
I think it's the right place to start. Without having gone deeper into it, I can't have a super informed opinion. I just know a lot of other views that's going to come eventually from various places.
Like what?
Like the mechanism design, I think is important. I think differential games are super important. In Control, for instance.
But so, for example, hooking this into our machine learning stuff is one important piece.
Mm-hmm.
And there's a need to understand how those designs mesh. Hooking it into the control theory stuff, how would that work?
That is what control design is. It solves games.
I understand that, Roger, but we have a control theory framework and it has functions that accept different kinds of things. And if you feed it, a game object, it's going to be poisonous and the animal is going to die.
Oh yeah, no, it doesn't deal with the same things.
Right, but that's what I'm asking. As I'm asking, what do you need? Because the thing
I don't know. I mean, I don't need anything from this. This is Matrix games. I don't think it's
okay. But so can the control theory stuff? Just like I'm saying, what we would like it to be the case is that, a machine learning, some random neural net should be able to be put in as the learning thing for game learning here. That's what I'm suggesting. And so that it's easy to do that. So now I'm asking in your mechanism design thing, if I don't know, a PID controller or something is I have no idea whether that's a
no. Mechanism design is much closer to this. This is like how do you incentivize people to use your new data center? How do you incentivize people to be truthful on their dating app?
Okay, but I'm asking the question when in our control theory framework, we have a whole bunch of functions.
Yes.
How would those plug into what you have here?
I have no idea. They don't. I mean.
Okay, but you're saying mechanism design is something that comes from control theory.
No, mechanism design, it's a stupid name because of course there are mechanisms all over the world. But that academic discipline that deals with mechanism design, what they design are kind of like contracts in a way that incentivize you to do the right thing.
Why am I running? This is a version. This is the wrong version. Anyway, never mind. Okay, this is not supposed to be this way. So I'm just trying to understand. In this whole setup, is anything here something which should interact with this game theory stuff?
No.
Okay. So there's no relationship between control systems. I find that hard to believe. I mean, I thought in economics, for example, that there were sort of common. Okay. Well.
No, I don't think that you should try to get them to interact at this point.
Okay. Fine. All right.
I just have one other comment here. So on the iterative game stuff, there's a lot of complications that come in with population dynamics and spatial versions, et cetera. What's here is very nice for the simplest case of that, and like what you saw in Axelrod, it gets that correct. But as you want to generalize this and want to apply it to the kinds of things people do in iterative game theory, they're going to want more control over some of the things which here are like hardwired as the simplest decisions. So this is still a good start on all that, but specifically the iterative game things here is going to want more ramification later. It's going to want to have more ability to control what populations you have, how they interact, and and those non-game aspects, so to speak, of the
Look,
dynamics.
my assumption is that there is a game nest list, effectively, which says, in every round, take what I had before and figure out how to get what comes for the next round. Is that a fair way to think about it?
Yes, and there's different sort of formulaic ways that are commonly looked at for how to do that based upon previous payoffs.
Right.
But the point is that who actually played the game with whom out of the previous population set is handled in different ways in some of these setups. Some it's everybody has an equal probability of playing everyone else. Someone it's everyone actually plays everyone else with with finite weights on them, etc. So right. Those aspects wind up being the extra level of variables above the one-shot game itself that are parts of the iteration.
All right. So basically, this is the way to think about this: is there's a kernel that is like in nest list, the function that you're applying, and then there are things like, fold pair lists and other complicated functional programming things where they are basically controlling what gets fed into each level of the iteration. Does that make sense?
Yes, and some of these methods of just having a simple ODE to solve to find the population dynamics are not going to work in that case. You're going to have to do something more discretized and so on.
So
go ahead.
This is something like a mean field approximation of
yes.
a realistic dynamics, for example. So there is no spatial information, for example.
Right.
There is no connectedness information, etc.
Right. But so what Jason is saying is, in general, the state that is iterated upon by the game kernel could be some more complicated state that could, for example, have spatial information or graph, a graph or something like this. And in addition, the way that the game kernel acts on that, I mean, it's reminiscent of things like, for example, we have functions like block map that will take, an array and decide it's going to pick out these 3x2 blocks or something to apply a function to. And then the function eats, I think it just eats the flattened list of things. But the block map function is responsible for deciding what piece of the state to pull out to feed into the kernel. Does that kind of
right? That makes sense. I mean, I think what we're going to want here is something like a game population evolve or something, and that's generic like that, and where this would be a special case within it. And then all of the other stuff underneath here for the how you use ND-solve to get the dynamics would then work in that case.
Right. Sounds more or less right to me. I mean, I think the thing we're talking about there is sort of functional programming where there are different ways to collect arguments to feed to the kernel. And then what you're saying, I think, Joseph, is that there are particular ways to set up those kernels and those ways, like the mean field case, where essentially you're just taking probably, in effect, the mean of a bunch of values.
Yes.
And then feeding in a single value into the kernel. The kernel expects only one value, and it's going to generate, I don't know, it's one or some matrix of values. But so I think there's probably a nice design that can be made that sort of allows for the general case, even though maybe at the beginning we don't implement the general case, we just implement some named cases that correspond to particular, common things. And we have deeply run out of time, and I am supposed to go work on chemistry here. So that was really good, and to be continued. And thanks to everybody who was here. I see we have, we have several visitors here whose opinions I would love to get, but we really ran out of time. So I think perhaps those can be gotten offline. All right, well, thanks a lot, guys. Thanks to folks on the live stream. We are about to do another live stream about chemistry for those who are interested in that. Okay, see you all soon. Okay, for people joining this live stream, busy day today. We were just doing game theory, now we're doing chemistry. So, okay, that's cool. Okay, improvements to molecule draw. Okay. Oh, we have plot themes for molecule plot 3D.
Don't get your hopes up before you reach the end of that sentence. It was more of a.
Oh, post 12.3.
Sorry.
Fine.
I should lead with that.
Yeah, okay. Okay. New functions, molecule name. What is that? Why is that not just common name?
Let's see. Because common name, to my knowledge, exclusively goes to the knowledge base.
No. But that's just what we've chosen it to do.
No, yeah, I had the same question, because there isn't one. There isn't a unique one. There are many. It's not a common name, and there are many possibilities.
I see. So if I were to type in some random thing here,
you would need to wrap that in molecule, the string.
Okay, that should be unnecessary.
Okay, I'll make a note of that.
Wow. Okay. Do we believe it?
So this is one of the functions that I use all the time. That's currently in the function repository. We've had a fair amount of.
What is that? 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 Why am I seeing some weird thing about querying cactuses?
So I can. So that's one of the questions here. So we're querying a few different external services when you make that call. And so whether we need to say that we're calling that service or not. Okay.
I don't think it's relevant to people unless it fails. I mean, unless it's going to take a long time.
Mm-hmm. Well, so it can take a long time, which is why I thought it needed some.
Well, so then in that case, we give a progress monitor, but that progress monitor with the black there it doesn't follow the progress monitor guidelines. Did you make that as a custom thing?
No, so I'm using evaluate with progress, but I'm new to it, so
Okay, it doesn't look like it's quite the right form for that. But now, if I put in what can I put in here? Help me out with a random chemical thing, something weird here. If I put a sulfur on the end, is it going to do anything? I mean, is it going to? Okay.
It's very easy to find a molecule that nobody has put into any database.
Okay, fine. But isn't there doesn't IUPAC just define a way of naming things that will work for pretty much any molecule?
Right, but there's no software out there that will generate them. Or if there is, there are some software that will generate molecule names, but they're all closed source.
Systematic. Well,
they're all expensive. Jason wanted to say.
But this is bullshit. I mean, come on. There's an algorithm, right? IUPAC defines an algorithm for doing this. It's not even a terribly complicated algorithm.
But it's gigantously long.
What? The algorithm?
Hundreds of pages.
Yeah.
I see. So that's the problem. So the problem is there is a standard for naming molecules, but which somebody made up, and some set of people were sitting in some room one day and they said, well, what should we do in this case? Oh, let's add this paragraph to represent that case. And then poor software people have to go implement what that paragraph says. Is that basically the point?
Correct. Yes.
And people have done that painstakingly, perhaps. And does anybody care?
I believe it's just definitely needed in the pharmaceutical industry for filing patents.
Yes.
Okay.
And the name generated in that way is an unambiguous representation of the molecule, or intended to be.
Okay. So it's a separate project to go and just implement, or to somehow license some implementation of the, given the smile string or whatever, what is the name? Right. That's a separate factored project, but what's being done here is to cover a large fraction of useful cases. Is that correct?
Yes.
Okay. So presumably there should be some method. I mean, presumably we could do something where there's a service connection that uses service credits to go query some, pay database for the more complicated cases. Is that a true statement? If we cared.
Yeah, yes. If such a database were available and had an API with
Okay, well, fine. That's a separate separate thing. I think there might be somebody in the company who might know how to get access to that. We'll talk about that separately.
Yeah, it wouldn't be a database either. It would have to be an algorithm for as a service.
Right, I understand. Okay, but so, I mean, let's separately, we can talk about how that might be achieved. But right now here, there are external APIs that you are querying, correct? For in certain cases, is that a true statement?
Correct.
That was what I saw with the cactusing.
Right. So first we check the knowledge base, and then we go to PubChem and then Cactus.
Okay. Okay. And so, right.
We are saying you should have something where we can say which service we are using. With only one PubChem for that.
No, look. There should be a method option to molecule name, which says something about. Yeah, you should have a method option here.
Okay.
Okay. That allows you to specify those things and possibly even the order in which they're tried. Now, in terms of what the progress monitor says, the standard way to deal with the evaluate with progress, so to speak, is if it comes back in a few seconds, don't bother to say anything about it. Right.
Right. I set the delay to 1 right now, but
I would have it longer than that. I think the likelihood is it's going to just work. And if it doesn't just work, it's because you're not connected to the internet or something, and it's going to fail forever. Am I making sense? I don't know. I don't know how many. I think it's. And then what you should do, and I'm not the expert on how we're setting these up, but you should make it clear. I mean, when somebody sees something about cactuses here, they're like completely confused, right? You know what cactus is, but other people do not. So I think you should say something like querying external cactus service or something. Did you understand what I'm saying?
Yes, and so I mean, so should it be just querying external services, or
no? I think you should say which service it is, because
Okay.
it could be that one of them is down, or something like this.
Right.
Querying external cactus service ... querying external or maybe just querying external service paren cactus or something. Querying external service yeah, okay. All right, but so there's some business development stuff to do around, which we can talk about separately, to do with figuring out whether we can get access to more sophisticated algorithms here. Okay, so in this, okay, so that seems kind of lame. I mean, what happens? So there might be 3 different. Could PubChem have 3 different molecule names in it for a single molecule?
Yeah, no, PubChem can have several. Yeah.
Okay, so what are we going to do in that case?
So we had differences of opinion in the group. Others said that we should be able to return the list, and also an association with service goes to and then list. I myself want generally a simple function. I want a function that is just going to give me
I
one
think
string.
we can get both of what we want. I mean, so I would have a second argument. I would say the first case is just give me a name, right? And the second case would be you have a second argument here, which would say something like, let's see. I mean, we'd say, I don't know. I'm making this up, and this isn't a very good thing, but something like all names or something. Names list. See what I'm saying? And then that would give you a list of all the known. I don't know whether that's the right thing or whether what you want to get out is something which says, PubChem reports these things, a list of names here. So-and-so reports this thing.
That's what the
very in keeping-
association was going to give.
Yeah, that's very in keeping with what Jan and Bob were suggesting.
That's
Well,
what I would prefer if I was using it.
Well, why don't we just have a second argument that will give you that? And the default when there isn't a second argument is what Jason wants, and just give a single name.
Yeah. So and then the second argument could be so I would think to make the second argument the string name of the service or the symbol all. But
that's fine. That's sensible. The only problem is if you tell me that PubChem can have 7 results. Oh, I see what you're saying. It just returns a. Okay, so then the default. Okay, so the default would be automatic, which means give me 1. Then what would happen is if you say PubChem here, then it would give you the list of PubChem results. Is that correct?
Right, which could possibly be empty. Yeah.
Right. And then all would give you the association of all of them.
Yes.
Seems sensible to me. Now, this string here, presumably there's a service connection that is doing this PubChem thing. Is that correct?
Right. PubChem is through a service connect, and ChemSpider is one of the external services I call has an API that's far too simple for service connect, and so I just make the call myself.
Okay. I mean, it might be nice to package it, in a service connect. It's a cheap service connect, presumably.
Right. I reached out to them, to the, Christian's team, and so their question was, do we need to do that?
Well,
Yes.
probably the answer is no. But I mean, it might be nice to do it, and they are supposed to have a lightweight framework, which may not be ready yet. Once they have their lightweight framework, I would suggest doing it.
Okay.
If it changes, then we just update the Service Connect, right? We don't have to update the code then. It should be going to Service Connect.
Well, and also the other point is that if there's a standardized way that the Service Connect is called, you could add another service here and have it just work by adding something to the service connections. Right. Good. Okay, on we go. This looks nice. Find molecular identifiers.
Right. And so for 12.1, when
what happened?
Molecule instead of molecular. For 12.1, when external identifiers were introduced, I put these as properties for the molecule. But Tony pointed out, and I ended up agreeing with him, that to have a molecule property, make an internet call without it when it wasn't clear to the user that it was going to do so, that it's not the best practice. And also there would be a case where some of these services would hang and you would be calling for all the properties on a molecule and wonder why is it taking so long. And so it's just more clear if it's a single.
So wait a minute. So you're removing it from the molecule properties?
Let's see. So they were de-documented. You can still ask for the property and it will still work, but it's not on the documentation page. And so it's going to. Would be the documented way to get the external identifiers.
What's our standard way of getting an external identifier for another?
Entity value is the only way that I know.
Right.
I see. But so if I want to get the wiki, if I have a person and I want to get the wiki data ID, how do I do that? You know what I'm asking? How do I get that?
Yes, and I believe linguistics are hooked up for that.
So if I say something like Alan Turing wiki data identifier,
that should hopefully work.
It's not looking like it's working. Oh, what's that? That's weird.
Dropped it as.
How do I get
I think wrapping Wikidata data around it. Also not, sorry. We need a second argument.
Specified property. But by the way, this should error out if it's not going to work. This should explain that it has too few arguments. It shouldn't just fail.
Yep.
What on earth should it be?
No, there's a ref page example that does work. So it doesn't.
So Wikidata ID, right, was the name of the property.
Okay, I'm now completely confused. But then the one argument form, what's it supposed to do? Michael, what's the one argument form supposed to do?
No, right now we don't have a documented one argument form.
Okay, well, so fine. So let's make it error out.
Yeah, yeah.
Okay, but so this is a way of getting that external identifier. This thing here is an external identifier. Is that
but
correct?
It's very special. It's not a general. I mean, we have 100 or something that just works for Wiki to get this identifier.
Right. I contacted Tony about whether we would ever want a general find external identifier function, and we agreed that it would be useful, but hard to implement generally. In that
it wouldn't be quite clear what the argument of this function would be.
Right. So for every particular, it's not clear. I mean, what object types would have corresponding identifiers besides entities? It wasn't clear. But so he suggested I might be better off just making one specifically for molecules.
And wait a minute. Lists of external identifier objects.
So some identifiers are supposed to be unique, so there should only be one compound ID, but some are definitely not, so there would be multiple substance IDs. And so the default is just to always use a list.
I mean, okay, so the basic issue is you've got a thing represented symbolically in our language, and there is an external database, Wikidata, PubChem, whatever, that also supposedly has a thing that represents the same, object in some way.
Yes.
Yes, that's correct.
Yeah.
Okay. And so why is it that we don't want to have a general version of this?
Because the thing we can rarely represent other than an entity. Molecule is an exception. We don't have say. Yeah.
Or more to the point, they're not the polynomial x squared minus 1 doesn't have any particularly useful external identification.
Yes, exactly.
So
that's kind of the other way around, yeah.
Right. So the point is that there are external identifiers, like we could say, given this geoposition, what is its, what 3 words designation or something? I think we have that particular, Well,
but say it's like, think on the big ones. Its DOI is 200 million, and other than say a string or something like this, we wouldn't have a representation of it.
Well, not yet. We're planning. Hopefully, we're going to get back to that bibliography stuff before too long.
But then, wouldn't it not be the identifier itself? Like on the DOI, other than going to the database, we can infer no information. But for molecule, we can infer non-trivial information without the outside world. Because we have a representation of it.
Yeah, okay, fair enough. All right, so let's see. Find molecule identifiers. I'm troubled by the S at the end. But I mean, and what's the default if you just give one argument? Is there a default?
It returns an association with so if you scroll down, there's an example, I believe. find all available for is at the bottom.
You might have picked a simpler molecule, then there might have been fewer.
It was tricky. I first chose water, and there are a lot of substance records deposited for water.
Really? Let's try it. What happens if I say something like, just for fun?
That should be present there.
What is finding chem? What does that mean?
So those are the specific external identifiers. So this happened to Bob earlier, and so essentially we are using a service connection, and this is in the system.
But wait a minute.
In order to use that, you would need to go and create a ChemSpider API key. So I could disable it because this is not pleasant. But I added the API I added the API key for myself several years ago, and it's just worked ever since.
I understand, but that's not good enough. I mean, why don't we go make a deal with ChemSpider so we don't have to do this? Right? We've interacted with those guys for years. Surely we can figure out a way to avoid this, because this is going to kill off anybody who wants to use this.
So
okay? This is a non-starter. It's not going to work.
So I can remove ChemSpider from the default
list. We should go make a deal so that you don't have to do this. Right? That's the right answer.
I've made a note of it.
Okay. Okay, but I wish you'd kind of like told me before I tried this, something like this was going to happen, because this is a completely not something that can happen with our, the only thing we can do, which we do with some functions that use external services, is to put up some kind of terms of service screen. Right? And that would be probably the deal we would make here. Am I making sense?
Yes. So, I mean, I'll talk to Christian and Alan about.
Yeah, they're not quite the right people, but they can start there.
Okay.
Okay. Okay. So, and again, those I don't know why that isn't in the progress monitoring guidelines, but I mean, it should end ... and things like that, and it should, it's not the right progress monitor message.
Should I check with Julio? He's the one who's designed?
I think so. I don't know. Somebody else might know.
Yeah.
Is there anybody here who's project managing?
Yes.
Yeah.
Okay. Well,
so, do you want the molecule record? Is this necessary, or do you also want the script here?
I'm sorry, what?
Do you want molecule required here in find molecule identifiers? It's not really needed anymore, right?
No, you don't. Obviously, you don't need to have molecule there. Obviously, it should just work with this. I don't know whether it will. No, so that's wrong, right?
Okay, you fix that, yes.
Okay. It's a little weird.
But useful for people.
I understand. I understand that. Fine. Okay. It bothers me to not have this be part of the properties. I mean, the fact that there's some random external service involved is just like a detail. It shouldn't be part of the story of what the functionality is.
So the thing that bothered me was when I would ask for all the properties of a molecule, and they should be computable and they should be very fast. And then you've got just this one that inexplicably takes.
Well, right, but that's forever. Just a stupid implementation problem, not something that we give, that we feed to users, right? That's not a reason to do this, right? That's a reason to think about the design of all. In the case of properties of a molecule, how do you ask for all properties of a molecule? Do you understand my question?
I do. Trying to remember.
Right. So you don't even know. So so this case is okay. So for example, if I say here, data set, for example, okay. Okay, 107 values. All right.
That's not a molecule, that's an entity.
Okay. Well, so what is the corresponding thing for a molecule?
That's a good question.
Okay, so then what is the thing that you're complaining doesn't work?
Let's see. So the exact syntax, let's see. So give me a.
Okay, so look, here's what I think you should do. Okay, I don't think it's a good idea to, I mean, it may be convenient if this is an incredibly common operation to try and find these identifiers, then have a function for it. But if this is some kind of hack to deal with the fact that it might be slow to query some external API because we happen to be using an external API this week, is, that's the wrong thing. And instead what we should do is, whatever the default give me all properties, which you don't even seem to know what it is, just should not include this property. And then you should be able to ask for this property using the same mechanism. But as a convenience, if you're giving the whole sort of card about the molecule, either we cache the result or we, right, which also would not be an unreasonable thing to do for many molecules, or we, or we don't include that in the list of things you get by default. Just like there'll be other things that we don't include by default because they haven't been measured for that molecule or whatever else.
So, okay, so the fact is I push this as the reason, but to be honest, I do think that this is a good function and it is a good.
But can you answer the question? How do I get all the properties of a molecule?
Well, so I haven't tabbed over it. So if you do molecule value of all properties, you get a list of all the properties available.
Okay, so that's a complete. So this case that you described is not a real case of it. Oh, it's slow. That's just not a real case. So we can take that off the table, right? I mean, there may be some case where we have to not include these external identifiers in our generic list of properties of a molecule, which would be fine, right?
So the fact is, I like molecule value as doing computed properties, and I like the fact that this is molecule identifiers. It's always going to go out and it clearly separates. This is something, it's not a computed property, it's something that we are getting from outside. So molecule identifiers isn't going to give you the smile string because we compute that. It doesn't give you the inch because we compute it.
No. Look, the fact is, no. I mean, this distinction is something which you understand very well because this is what you're doing and you're living it. But the question of whether the smile string I wouldn't know whether the smile string, I think I know that it's just computed, but I don't know whether there's some canonicalizer for smile strings that involves some external service. I have no idea. And I don't care, right? I mean, in other words, this distinction between things that we compute internally and things for which we go to an external service, if there is a canonical, if the thing for the external service is the accession number of this molecule, this CAS accession number or something for this molecule, then I understand that's something you're going to go to an external service for. That's a different kind of thing. But if it's something which fundamentally it's an algorithm, but we didn't happen to implement that algorithm, so we're going to an external service for it, that's irrelevant to the user. So which is it in this case?
No, that's not the case. Here we want an identifier, which is not a computed thing. Neither we nor somebody else can compute it.
No, I understand. So that's okay. By the way, I don't think we should call this find molecule identifiers because there's not a lot of the fact that that it's going to some. I mean, we don't say find because we have to, we say genome lookup, not find genome lookup, just because it has to go to a different computer type thing. Am I making sense?
Yes. So
okay, so you're saying molecule value is a property of the molecule, but I think molecule identifiers should also support the smile string and the inchy string, because the fact that those happen to be computable identifiers doesn't seem to me relevant. You see what I'm saying?
And externally, they're also referred to as identifiers, so the users are going to expect that. You go to Wikipedia on any compound, and Inchi and Smiles will be there under the identifiers.
Right. So I think that will be fine. I mean, so molecule identifiers would then return all identifiers, whether they're sort of a named CAS registry number or whether they're something like Smiles. Jason, does that make sense to you?
No, not. I mean, so let's see. So either we just take all of these and make them into molecule properties. So this is a function right now that returns always external identifiers.
No. Oh, I see. External identifier objects.
So so we can just scrap this function and fold those all back into being.
No. I'm not suggesting that. I'm
Okay.
suggesting something different. Okay. Molecule value, it happily computes computed properties, which includes the Smiles string, which is a computed thing, right? Makes sense? Now,
Yes.
the point that I'm making here is the notion of a molecule identifier should include okay, so the issue is these things are external identifier objects, not strings.
Right. The word identifier is used in two different meanings.
I see where Stephen's coming from, because anything that's not the chemical name or the chemical formula is a molecular identifier, strictly speaking.
Yeah.
Yes.
But this identifier in the function name refers to the external ones.
I know. So unless we said molecule external identifiers,
Okay.
which would clarify what that is.
How about?
But I agree that isn't molecule value. I agree that the external identifiers are probably not something that, because does entity value give the Wikidata identifier or not?
We do have a property. I'm not sure right now if it's exposed. But we have it immediately handy. We don't have to go somewhere to get it.
Right. So entity value, I mean, it doesn't have just computed properties. It has curated.
But only we look in our own thing. We know how to do it quickly and without complications.
What if we name this molecule identifier lookup instead of find molecule identifiers?
That makes good sense.
I like that.
Yeah, that makes good sense.
It is looking up external databases, which the user shouldn't care about in theory, but it is doing a lookup. So lookup in the name looks sensible to me.
I agree with you. But, okay, listen, we've clearly got much more to go through here. We've got probably another hour and a half of stuff, and I can't do that right now. So I think we should probably wrap it up for now and reschedule this for later. And I look forward. These all look very interesting. Sorry to make the one that was supposed to be trivial not so trivial. Is there anything, just one last thing for 1 minute? Is there anything cool to see here, just for fun?
Let's see. I mean, so maximum common substructure has gotten a bit of a revamp. And so,
no, I understand. I'm just asking if there's some interesting thing to just see. There's just a cool thing that
molecule align.
Yeah.
The estradiol and resveratrol example.
What does align mean in the case of I mean, well, I'm about to find out.
Indeed. Further down. That not that one. Here we are. This one.
People are suggesting we have more tungstens in here. I don't know how much we can do on tungsten chemistry. Okay. So what does this mean? So this is which pieces of the molecule. So I mean, is this sort of preparatory?
Okay. The way it works, you give it a molecule as a reference, and one or more molecules will get aligned to it. you have to specify which atoms are important for the geometric comparison. That's the third argument. And then it will align the molecules in the second argument to the one in the first argument by minimizing the distance deviation between after doing a rigid translation and rotation
cool.
on them.
Yeah, this is definitely cool. Very nice.
And this example, the resveratrol is an estrogen. It's a hormone disruptor, and it matches very closely to the estradiol structure.
Very nice. Okay, this is interesting. All right, I look forward to this. We'll do it another time. So thanks, guys, and
Thanks.